Let me speak just a little bit while people are coming in and getting settled. The earlier panels underscored a very common point, which is that we are transitioning to a new compute platform. In this case, one that is so dramatic that we need to think across categories and remain open to new types of definitions. Broadly, the compute platform involves cloud architecture, but it also takes into account areas like mobility, tablets, phones, sensors, RFD, GPS, information from independent data marts, information from partners, awareness of all these people, because of this very flexible architecture with many, many touch points going into it. So in addition to that, it goes into both structured and unstructured databases. The unstructured ones have come into their own in the past decade or so, thanks to very powerful online companies such as Google and Yahoo, which needed ways to organize all kinds of information, which had been essentially rounding errors if stored at all, but became critical and quite valuable, they found, for their businesses. These generalized to value sources for others as well. So all of that goes into a even more dynamic storing and computing system than we have had before. And these are the big databases that we have today, adding to at some furious level. In 2003, the amount of data created in the world was equal to all of the human conversations. And I did the math the other day, and it's like 218 times that now is created annually. Largely video, but also an increasing amount of online and sensor data as well. All of which may potentially be of value. The big data is the application of this insight that all art, all science, and all commerce is based on the identification and exploitation of novel patterns. So if we have all this data, which we've never captured in one place before, and look at it, we know there are patterns in there that can be extracted and manipulated to create value. That's a terrific insight, but it also raises a number of issues. What are the areas that we should attack first? How do you build for this? How do you spend correctly for this? What are some possible issues around privacy, competitive intelligence, regulation? How are my competitors doing? What am I doing? What is a best practice in a new field? How will this affect my organization? How will I find appropriate talent? And what are the really effective sources of value in this practice? So we're going to solve all these problems in the next 40 minutes, and then there'll be a little Q&A where you'll congratulate us, okay? The plan is that we'll try and get a conversation going among the 4 smart guests. You know their names, and I'll ask them to talk a little bit about themselves and what they actually do in the world of big data. And then we welcome questions from the audience as we work through this problem together a bit. So please, gentlemen, let's just go down the line. I'll start with you, Michael, and say a little bit about what you do inside the field and what you think 1 or 2 of the key issues in big data are.
So my name is Michael Chewy. I'm a senior fellow at the McKinsey Global Institute, which is McKinsey & Company's research arm. I do research on the impact of some of these major trends, and big data is one of them. Almost exactly a year ago, we published an embarrassing long report that basically said big data is a big deal. Thank you very much. Okay. But we continue to do research in the area, and then with my colleagues, try to help some of our clients address some of the problems that Quentin mentioned.
So I'm Tom Davenport. I'm a professor at Babson College, moving to Harvard Business School in a month or 2. My thing for the last decade or so has been analytics and how companies compete on their analytical capabilities, build their analytical capabilities, pursue analytics in marketing and supply chain and various other domains. I was hoping I could retire talking about that, but then big data came along and I had to get busy. So I am now working on a little bit about, how does big data and big data analytics differ from conventional analytics, and even more, what do data scientists do? What are they like? Is it true that they're just quantitative analysts who live in the Bay Area, which I think I've determined is not the only attribute they have.
There goes your job security, Michael.
And does everybody need one? Let's hope not, because there aren't very many of them around. So.
Well, how has it changed your thinking? Well, first off, everybody in the room has some, well, everybody except me has some background in statistics and analytics. And how does it differ? Big data, aside from the fact that it's big and unstructured to some extent, how does it differ and how does it change your thinking since you were steeped in analytics?
Can I also ask how you managed to retire to Harvard?
Yeah.
I don't know what that says anyway.
He had planned to retire.
Post there, you know,
Second
rely on
career.
past knowledge.
Yeah, nothing happens there.
I think it's the lack of structure that is the biggest factor. The size, people tend to talk a lot, you know, the petabytes is an impressive
exabytes.
number, but I think it's the lack of structure that's the big deal, and I think the tools that take unstructured data and apply structure to it are the primary tools. I mean, that's essentially what the Hadoop ecosystem is about. And splitting it, obviously, across servers, but that might even happen with moderate levels of size, wouldn't have to be that big. And I think to me, the really interesting thing about it is, you know, data scientist, it's one of those titles that's like knowledge engineer, beer flow coordinator, jobs that I wanted as my job because they sound really cool. But now I think, there's a lot of plumbing involved in data science. People really have to work mostly on data management related issues. It turns out that the analytics often get short shrift. There's not enough time and energy left over to do anything but report on it and maybe do that in visual format.
James?
So I'm Jim Noga. I'm the Chief Information Officer at Partners Healthcare. And you know, when you talk about unstructured data, I don't think people really realize in healthcare, they think of lab results and that and structured. The majority of data is actually unstructured in a textual format. So being able to use natural language processing, put some structure around that data, and really get into what's called evidence-based medicine, which is really looking at treatments, looking at the phenotypes of patients and the outcomes, and really having some empirical evidence as to what is the best course of treatment. That's one of the efforts around big data. Obviously, public health surveillance, big data comes into effect in terms of, can I detect a potential outbreak or epidemic on the horizon? So there's a lot of research in terms of collecting data in the ER, aggregating it, and really looking for patterns. There's pharmacovigilance. What's that about? We know at Partners, if even our small data set, if we had been doing the right analytics, we could have probably predicted the problems with Vioxx, you know, a year before it really became to light in terms of, you know, causing particular heart conditions.
How might you have predicted that? From certain patient outcomes that were on the periphery or in the drug itself?
Because we have a research patient data repository that we take all that phenotypic data as well as the medications, and Kaiser likewise believes, you know, they could have predicted well in advance. So, but what are the issues? It's around privacy and really being able to crunch that data. I mean, there's other levers in healthcare in terms of the application of big data in R&D, obviously. But the really big thing is trying to get that evidence-based medicine. In fact, McKinsey in the report that you referred to said that the value of big data in healthcare is $300 billion annually. In the US, $200 billion of that being a reduction in healthcare spending. So some really great opportunities. And in some sense, healthcare is still immature with the exception of research in terms of big data analytics. We're just starting to really start down that path, and we're in the embryonic phases, although big data, generally speaking, is in the embryonic phases.
Mm-hmm.
300 billion, that must be at least 1% of the US total, huh?
Yeah, it's
Shwetan?
actually 8%.
Really?
Yes.
Mhm.
Shwetan?
Sure. I'm Shwetank Shah. I head the IT practice at Corporate Executive Board, a research and advisory firm down in Washington. For the past year or so, we've been working with about 24 global companies and 5,000 odd employees. They're trying to understand how people make decisions with data. So while we're interested, and CIO is certainly interested in all of the plumbing we've talked about, we're trying to understand, well, fine, even if you got all that data to them in the right time in a useful format, what would people do with that? And it ties in really well with one of the themes from this morning during the MIT panel when we heard about the untethered enterprise and decisions being really pushed to the perimeter. So you can have all the smart quants sitting at the corporate center, if there's such a thing, making lots of interesting decisions, but equally valuable, if not more valuable decisions are being made by your customer service reps, your retail POS people, hotel managers, whatever, at the periphery. And how well are we doing at doing that? It turns out that we're not doing very well. About 20% of our sample bias to people who just go with gut. So they don't care about the data. I know what I'm doing. I'm just going that way. Another 40% of the panel are folks that, when confronted with data, want more data. Analysis paralysis. It turns out only 38% of a very broad sample, a global sample of employees at Fortune, roughly 500 companies, only 38% were informed skeptics. They can actually blend data with judgment and come to decisions that, even at the individual level, drive the business forward. And so we're very interested in how do you increase that base of informed skeptics, and what does the IT function need to do, and what does, frankly, the business need to do, because both those organizations have fallen short, and I think are still trying to catch up to be charitable.
You raise an interesting question there right away, which is, big data has its roots, if you will, in online companies. But is there value across all industries? Are there industries that are particularly ripe because they were not closely observed before, but now can be? Is that model that in online, everything's being tagged, everything's being stored? And that could arguably extend to pretty much every part of the economy. Do you think big data will be universally valuable? Do you think there are specific industries where it's more valuable? I mean, you mentioned healthcare. There is this, I guess we'll call it waste because we can have all this savings. And retail.
Sure.
What else pops to mind as particularly right?
Crudest ways to look at the metric all CIOs love to hate, which is IT budget as percentage of revenue, and you look at the sort of FS firms, and they're very, very data intense. Most retailers are extremely data intense, but so many organizations, even on the other side of the curve, mining organizations, chemical organizations, are spinning off data in their supply chain, spinning off data in customer service. And it doesn't have to be gargantuan data.
Yeah.
To be interesting data. How do you make sense of that data still is a valid question. I was out in London with an airline organization, and they're actually giving iPads to the flight attendants with everyone's history. Anyone who's a member of their frequent flyer program, all of that history is contained with a little icon of your seat number. And it's up to the flight attendant to sort of look at that person and see if that person, say, for example, lost their bags 2 journeys behind, because they have all of your big data there, and come and give you a glass of champagne, even if you're not in business class. And you're trying to push that decision out to a flight attendant who is massively stressed trying to get the plane, out the door.
Yes,
how do you get that to actually happen?
And at the same time, that is such a creepy thing to do. Walk up to me on a plane and say, "Here's that glass of champagne from the time you lost the bag, and you met Betty in Newark, and like this."
I don't disagree. I don't disagree. But would you have liked to gotten the glass of champagne? I don't know.
Yeah, that's fantastic. Yeah. But
if I just build on that comment and your question, which is, we really do believe that big data is going to be important for every sector of the economy. We came to the opinion that the effective use of data is going to be a basis of competition for pretty much every firm in every sector.
Yeah.
Now, that being said, are there sectors that seem to be farther ahead? Yes. Now, some of them are driven by pure competition. If you have to compete with one of the online guys, like you're in retail, you're going to have a lot of incentive, and we're seeing those be some of the industries that have moved ahead farthest. And they're ones that Tom has helped historically over the years with analytics as well. But we also found some surprises. There was a reference made to financial services industries where you would think they would be ahead because they've had data, and maybe some of you have had data for so long. And yet what we found, for example, in a lot of Western banks is that the lines of business silos had become so strong that, in fact, the idea of sharing data is just very, very difficult.
Wow, bad at sharing. Who knew?
Even though it's relatively structured, I mean, it wouldn't have been that incredibly hard. The only thing, I think there are probably some industries that may never get there. The fashion industry, I'm not sure, for example. There are opportunities, but I'm not sure they'll ever do it. But I was talking last week to one of the board members of GE who I knew they were building this software and big data center in the East Bay of San Francisco. They were supposedly spending $1 billion and wanted to hire 400 data scientists, which I thought was a pretty aggressive move. But I heard last week, no, it's $2.5 billion now and 800 data scientists. I don't know what fraction of the total population of data scientists that is, but it's pretty high. And that's mostly for industrial products, things like locomotives and jet engines and so on, to try to figure out how do we harness all the data coming off of those and predict when they're going to fail or need to be serviced or whatever?
It's funny you should mention fashion. Yesterday I was with a guy, he helps online retailers crunch a lot of data. But there were implications for fashion, which were that they were looking at, he was extracting customer comments about products and using it to tag products with other attributes. I'm sure I can share this one. 2 different customer comments used the term Las Vegas in referring to a woman's top. One said, this is great for Vegas night at work, and the other one said, I'm going to really enjoy this on my trip to Vegas. And so Vegas became an attribute. And you would.
Sure, it wasn't a missing top that was.
No. The point is, it has other associations, and this is, underlines something of what the MIT panel was saying this morning, which is, you're in this world of contingency, and data has different sorts of identity depending on its application. Like now that's a term somebody used in reference, but you can use that to upsell, or if there's some penchant to like these things. And so that fashion object, and likewise that fashion object in terms of a supply chain, is extremely valuable. So fashion will take it on in other ways. And yes?
Well, I also think, there's the traditional data crunching analytics, but more and more I look at big data as an opportunity is, can you influence people's behaviors? In other words, and try different postulates and theories and see, especially around preventive medicine and home care and preventive care and people taking care of themselves. What works? We've done some experimentation that gamification actually works in helping people if you're doing things like trying to control their diet or getting them to take their medications. But to do that, you have to collect the data and do the analysis. So analysis rather than strictly on failure rates, and that is using big data to really find out how can I influence a person's behavior.
Sorry, go ahead.
No, I was just going to say, I think that's one of the great enabling things you can do with data now, that in fact you can actually start to view the world as a place where you can conduct experiments. And that's something that we haven't been able to do before. People in healthcare have done it for many years, but now we're seeing marketing experiments, we're seeing experiments in supply chain. Eric Brynjolfsson this morning made reference to, this idea that it's nice to have a control group and a treatment group. That really fundamentally changes the way that you make decisions now. To view places as a place where you can conduct experiments. And again, that changes the requirements for managers to be able to, back in the day we all studied, or many of us, studied the scientific method, right? Creating a hypothesis and, having controlled experiments. Those are the kinds of things now we can do in business and hadn't been able to do before.
My favorite example is a retailer tested whether lobster tanks actually sell more lobsters or not. And probably not the most important decision they make, but if you're going to
sell lobsters, it does.
Put in a lobster tank. I said, well, do they? They wouldn't tell me. But finally, I found a guy who was retiring who spilled the beans, so to speak, and he said, well, yes, but only if it's a neighborhood where people bought lobsters in the first place. If they can't afford lobsters, lobster tanks make no difference. So.
Well, if they don't have money, don't sell them anything.
Exactly. Yeah.
Fantastic insight.
Yeah.
Thank you, computing.
Yes.
Let's just back up a sec. Is this a developed enough field that there are now best practices, that people can find good ways to start? And do those involve using the assets at hand? Do they involve public clouds, private clouds, blowing up the old system? What's sort of the best way to begin at this point? Is it well understood?
My point of view is there aren't best practices. There might be emerging next practices. But really, again, experimentation is extraordinarily important. I'll mention a couple of things that we've seen that seem to have worked. One thing we know that doesn't work is wait for 5 years until the perfect data warehouse is ready and data quality is at 100%, and then we can start. We're pretty sure that that's not going to be effective. On the other hand, hey, it's an election year in this country and many around the world, and the business of electioneering has greatly changed with big data. And you don't have a whole lot of time. You have a few months, you got to get this done. And oftentimes you can throw a whole bunch of fairly dirty data into a room, often with younger people, not always, who are data scientists, at least maybe not by job title, but that's what they do, and are able to extract some value from it. So I think one of the things that you say is conduct experiments. You know, that fail fast, fail cheap kind of thing is true. But the other underlying point about it is we often find people over-specify on data quality because they're used to, you know, if you're the financial industry, you can't get a bank balance wrong, unacceptable, right? But if you have just the right amount of data that will give you a few more points of conversion or get someone more likely to go to the polls, that's actually going to drive a lot of value. So don't over-specify data quality is something else that we throw out there.
Yeah, I just want to build on that. You know, we actually found that in organizations where the reports actually were tagged with some sort of meta information color, for example, that alluded to the quality of the data, just red, yellow, green, and you were upfront that some of this data was a little dodgy, but you gave that information to your, you know, whichever group, the finance group, the marketing group, whoever was asking for it, that those guys actually got off and got working faster than where you sort of spun your wheels trying to get to, you know, articulate the best data quality.
Well, if they find out down the road that their certainty is undermined by corroded data, that's a much bigger problem.
But I think you make your decisions differently as a manager when you say, look, these 3 bits of data I can 100% trust. Here's what, I mean, that's why you pay a manager to go sort of analyze and understand what's going on and make some calls, right? And that's a little bit of the test and learn. Make some calls, learn how to, and figure stuff out and iterate and get better.
Well, Jim, what were some of the first things y'all did at your company?
So I think iterating is very important. So in genetics, right, big data problem. We don't understand everything about every variant. So what we find, you know, you do a gene mapping, you sort of run the analytics, you come to some conclusions. 2 weeks later, that can change. So, you know, you need to think.
Because new data comes into the
New
mix.
data comes in. So you almost have to, on an iterative basis, be going against that big data to really call out, you know, what are the salient points that I need to bring forward either to a physician or to a patient. And
sort of in an era of no final truth. It's just the best guess at the time.
Exactly. I think we're all trying to converge towards that final truth, but yeah.
Elusive.
Yeah, I think one best practice in big data is to not view it as one final truth and set up a continuing stream of analysis, decision making. I mean, the interesting thing about, I'm trying now to find people who can talk about how big data changes their decision making, and many of them are saying, well, we're not really making any decisions, we're just looking at it as it goes by, which strikes me as not a terribly good use of managerial time.
Come to California, Tom. We make decisions.
But Quentin, if you think about the twist this throws in front of IT organizations, right, and Jim, I'm sure you're living with this, most IT shops have grown up working in an extremely sort of with structured processes, right, with HR, supply chain, finance, doing the ERP we heard about this morning, where you can actually model those processes and understand them and put little yellow stickies. You know, I used to do that for a living back in the day. The places where big data is lighting up opportunity, customer interface, innovation, R&D, you know, collaboration, those processes themselves don't lend themselves to structure. And so the folks who need to try and understand that and play with that need to be anthropologists. You know, they need to be able to human factors. They need to be able to understand how people relate and behave with one another. It's a stretch for the folks who are, and I know we're going to get to it a little later, but it's a stretch for the folks who are in IT to be able to pivot, to be able to do that at large companies.
Well, let's get to it now. I mean, this is an interesting issue for these guys because there are now pools in the organization that see a lot of data going by. And maybe they own it, maybe they don't. Maybe they sort of channel some of it out over to AWS on their own hook. And there are companies coming up like Kaggle and ClearStory that will give lay people very powerful tools for data analysis. And so is the CIO running the process, setting policy, asking people to check in? It really, I suppose, has to do with the character of the corporation.
I wrote a little blog post last week where I argued that it didn't really make sense for the analytics function to be in the IT organization. There are certainly some exceptions that are working really well. I mean, most of your clinical informatics group is, in a sense, an analytics organization, Jim, and P&G has a really good one. But I think, you know, IT is about solving relatively standard, common, large-scale problems, and there are those in analytics, but a lot of it is also about, finding the new thing, and particularly in data science, it's not as Shwetank said, it's not a well-structured activity at all. So it's, GE is putting its data scientists in the R&D function. HP has put its people in strategy, and one could argue that those might be more felicitous homes, I think.
Let's speak to this term data scientist for a minute. First off, what is a data scientist? And secondly, is there really going to be a shortage? Or is this a problem that gets taken care of?
So to the answer to the second question is yes. The answer to the first question,
it's taken care of, or it's a problem?
It's a problem, and it will get taken care of.
Money, right?
Well, if you believe in markets, there will be a clearing. Supply and demand will somehow meet. Prices will go up, and et cetera, et cetera.
I think they already have.
Well, yeah. So the nominal shortage of 140 to 190,000 in the U.S. economy is what we described as current course and speed versus what the demand could potentially be. We do think that there really is an extraordinarily strong demand that will continue to increase for these people. Mm-hmm. What we mean by these people are people who have advanced training in statistics or machine learning and can couple that with an understanding of the business in order to derive insight. If I could say something just controversial while we're in an institution of higher learning here, I kind of wonder whether or not we should just, stop teaching so much calculus.
Yeah.
Because, the world's a messy place. As you said, it's, and, there are some people who use calculus in the real world, some engineers, et cetera. But really, isn't it much more important to understand things like conditional probability that models the real messiness in the real world? So maybe we should teach some more stats and a little less calculus out there.
The other thing I would add that's particularly typical of data scientists is, and LinkedIn now has a classification of data scientists based on the skills they're most likely to have. It's basically hacking capabilities. It's the ability to muck around, munge with, people have various terms, with data. Lot of programming. Many of these people are, Pythonistas in a fairly substantial way. I'm not sure exactly why Python is so appealing, other than that it's open source. But they spend more time. The data scientists that I've talked to, and I've now interviewed about 25 of them, spend a lot more time doing data management work than they do analytics work. I hope that changes at some point, and I think we'll have better tools, and we'll have people who don't need PhDs in physics or whatever to do this work, but now we seem to.
But I really think you need people that have a curiosity and have that discipline of experimentation. From an IT perspective, I don't think the analytics belongs in IT. We have a small segment, but it really is an R&D function. IT to me is the enabler. We decide on the infrastructure, what computations can we do in the cloud, what do we need to do in a private cloud or in the security of our data centers. So that's what I see my job as. And I see myself having to understand the analytics, but not necessarily having the responsibility. That's strategy, that's R&D, that's clinicians that are trained to be data scientists.
When we were talking before, you also mentioned you have a function of, in some ways, setting security policies or being mindful of competitive intelligence issues.
Right.
If people can observe your algorithm, they can make judgments about what you're researching.
And that's very important. We have a big data repository for the researchers, and they actually hold very close the queries that they do against that database, because they're afraid of another researcher, based on knowing that query, what hypothesis they're testing, and that they'll have somebody write a competitive grant to what they're trying to write. So it does get interesting in terms of how much crowdsourcing will there be in the big data field.
It's very...
There was an article in the Times this morning. I don't think you wrote it, Quentin, but
the social science one?
The one where Bernardo Huberman said we shouldn't let people present papers if they won't share the data. It was a bunch of Google guys.
Well, if you're going to present in an academic environment, I totally get that. How can you peer review?
Let me add one more point about the data scientists, the sort of the rocket scientist group. What we found in our research was that you absolutely need to hire them for all the skills we've heard about: pattern recognition, iteration, experimentation. But the single largest lift, if you will, in increasing the analytic capability, the analytic maturity of the organization overall, was their coaching skills. because these guys are your force multipliers, right? At the end of the day, at some point, yes, supply demand will meet, but again, decisions are being pushed out, they're being made in your finance department, in your marketing department, in your corporate strategy department. You're not gonna be able to touch all of these. You can't hire enough data scientists. People who are gonna do this for a living need to be coached, and the people who are gonna coach them are the folks who actually know what they're doing. But to be able to translate that, most of these folks are people who do,
Right.
not people who can do and teach.
Oh, okay.
And so that is a really effective force multiplier to get, again, your overall insight IQ, if you will, up.
And they probably can't teach extremely complex statistical analysis,
Right.
but they can teach things like how to have a good hunch, when to turn it over to us. And this was a question I wanted to ask, which is, when you think about adding value, would you rather start with a problem and work backward, or would you rather, and for example, say, we need to get our email marketing return up and work backward through the data? Or would you rather think, where do I have a lot of interesting data of a good quality where there may be a pattern? Which would be the more effective thing for you to do?
So it's a messy world. We actually find that it's typically an iterative process. Part of the process is trying to understand what your most pressing business problems are, and then part of the process
And
is
try and associate data with that?
exactly, and vice versa. What data do we have available? But perhaps more importantly, what data could we have available? Because oftentimes people focus only on the stuff that they have within their own four walls. And there's so much. We usually find you can multiply the amount of value when you combine it with data that's available externally.
I know these guys, this company Factual out of LA, big data mart, and they have to work very hard to get companies to share their data and get data in return. But they do data cleansing and the quality goes up. And their argument is it's so much more valuable when you expose it. Jim, you probably don't think it's more valuable when you expose it, or you expose it in certain ways, I suppose.
Well, that's it. Well, when it comes to patient data, anonymizing it is a big thing if we're
Right.
going to get into big data and share across institutions. So it is sort of that, for the greater good is in healthcare. I think there is an opportunity. The research, not so much, but general surveillance and looking at evidence-based medicine, I think there are opportunities to aggregate data across multiple organizations.
Are you familiar with a company called Practice Fusion?
I am familiar with the name.
Oh, okay.
Yeah.
It's a cloud-based patient records management company for free. And the way they make money is when the doctor is writing a prescription or a certain cues come in that they might be writing a prescription, an ad can be placed for a drug inside the record management system.
Yeah.
And the other way to make money is that they find for drug companies test subjects. It's a far more efficient way to find, obviously anonymized, but would you send this guy a note asking if he'd like to be in a drug trial? And you can get paid a lot for that, obviously, because it's a huge time saver. Does this make anybody a little nervous?
I would say the majority of academic medical centers are already doing that or anticipating building that into their electronic health records is for clinical trials, being able to identify cohorts.
It's a commonplace then,
I think,
so I shouldn't worry about it.
Well, no, I think what you should worry about is, I do think the other side of the coin, as the patient, is there is a consideration for who knows what about me and how much, and in other words, there's HIPAA regulations in healthcare around privacy. And some of the concern that is if I have enough clinical data on you, even if I don't know your name, I might be able to identify you over time.
As somebody at Google said to me once, I don't want the name. The name is trouble. The name is noise. I can figure out who it is anyway.
Exactly.
Unstructured data, right?
Well, it's going to get me in trouble to have the name,
I think de-identifying data in a single data set works. As soon as you start to add other data sets, it actually gets increasingly easy to re-identify data when you're combining data from multiple data sets, which illustrates the power of multiple data sets,
there
but
will
also
be
illustrates
regulation
risks.
around this, and there already are regulatory models around this. Now, I might want to be anonymized during the drug trial. If it turns out I have a genetic marker for this and the drug is effective and I'm going to die if I don't get it, I want to be massively identified. I want my name so tagged on that data you can't believe it.
Right.
So there needs to be some kind of holding institution that can re-identify me to the set. And it has to be possibly a government or some secure third party that's away from both players.
And people trust the government in the United States to such a degree that they're the likely candidate to do this. Right?
Well, they impose laws, so yeah.
I'm
the FDA
trying to
is,
envision which senator
FDA
is going to sponsor that legislation.
the FDA will do it on their own hook. I mean, they're very worried about this kind of thing. What does genetic information mean for them when some drugs are lethal for 5% of the population but efficacious for 30% of the population, and the patient can identify who they are inside that mix? Should that drug be illegal?
I think the key point to my mind is that the technological capabilities and the creativity and the skills of the data scientists and the information managers and so on is so outpacing the ability of our, at least in the US and to a lesser degree around the world, outpacing our ability to create meaningful laws around it, that we better get used to the idea that regardless of the laws, we're not going to have a lot of privacy going forward.
Yeah.
I want to get back to your original question about framing inquiries.
Yes.
And you said you sort of start with the business problem and find the data to go solve it.
Yeah.
Or do you go vice versa? And I generally agree with Michael's position that you're actually going to go in both directions.
Yeah.
There are going to be interesting data sets that you're going to mine, and there are better ways to do it than just the sort of usual kitchen sink analytics model. But the other way, when you actually are looking for a solution to a known problem and you're mining through the data, one of the things we found is our own biases, the biases of the researchers going in, the cognitive biases about recency, about who we're working with, those things tend to make us sometimes stick to our original hypotheses even when the data disproves them.
Is screaming.
And it is very hard to unstick. I'm talking from CEO groups on down that we worked with, from patterns of, this is how we're going to go about solving this problem, even when the data is telling you something that's completely contradictory. Mm-hmm. And I know, Tom spent a decade plus doing work in decision making. Danny Kahneman and others have been doing some work, on behavioral economics up at Princeton to try and understand how we overcome our own biases. But again, I'm finding that very key in that first approach when you're trying to find data to usually prove a point on how you pull back from a hypothesis and actually tack. Mm-hmm. There's a whole thing built into how we operate that's hard to
Well,
uncover.
I put it to somebody in the business, and I liked this answer. They said, Monday to Thursday, I would go to an existing problem because it's just going to be much better for my ROI. I have set items I can benchmark, I can show improvement or not, I can learn in a more direct way. On Friday, I would seek good sources of data that had grown radically in the last 3 years, say, and no one had really been looking at it. And I and my group would brainstorm on what might be found in there. Save a little bit of, it's like an 80-20 thing. Save a little bit of time to look for these new sources of data that have come up that nobody ever looked at before, and you can do a lot of novel thinking inside that.
It's the analytics equivalent of the Google 20% time
If
thing.
you will, just stretch your brain. Think
yeah.
about your work in different ways.
The problem, though, and this is kind of the opposite problem that Shwetank described. I've seen a number of occasions where anomalous findings in databases were not acted upon. And you can start with, I think, the world's most famous data mining finding. It's safe to say that the beer and diapers finding is the world's most famous. I know the guy who did that. I don't know if you know this, Chuck. He used to work with us at Index, actually. Tom Blishock is his name. He did it for Osco Drug. And so you'd say, okay, what did you do? Did you move the beer near the diapers near the beer? Did you spread them out around the store so people have to weave a circuitous path and buy more stuff? No, we did nothing because we didn't think that it really held up. And that's often the case, I find, when people just find stuff and there's no hypothesis that people are trying to prove. So the downside is you stick with your hypothesis too long. The other side of that coin is if you don't have a hypothesis, you just don't take any action.
Mm-hmm. Your original question is, what are some of the big issues in using big data? And it's fun. We're at the Massachusetts Institute of Technology, but actually the plumbing's important, but it's this people stuff which is often hardest, right? Having decision makers make decisions in a data-driven way, acting on anomalous findings, having the talent that consists of data scientists. I actually think that stuff is often, as hard as the technology problems are, that stuff is often the hardest.
Teaching groups inside the organization to share better, getting data quality by exposing data.
It's actually more than that, right? Excuse me. So you could sort of lead these campaigns from the top down, saying we're now data-driven, we're analytics-driven, we're, we talked about this, the guy at Harrah's and Caesars Entertainment, and I think those are still going to be the exception. The real work of what drives in our opinion, what drives an analytically mature organization is where decision processes are formalized. So people actually have measurable MBOs, performance metrics actually used and not sandbagged. There's transparency in how decisions get made, and people feel that those decisions are made, even if they don't agree with them, they understand the underlying data in how they make them. That actually drives much higher overall analytical prowess at the organizational level, rather than a sort of a campaign from the top down saying we're now going to be all data-driven.
Mm-hmm. I agree with that. I was going to say, in reaction to Michael's point, there's one of my analytical heroes is a guy at Intel named Carl Kempf. Maybe some of you come across him. Very smart guy, an Intel fellow, one of these people who can do whatever he wants now. He heads a decision engineering group at Intel, and he's fond of saying, if you want data-driven, analytical-driven decisions, it's not about the math, it's about the relationships, which is striking when you hear that, in addition to his other titles, he is the chief mathematician of Intel Corporation.
Wow. We'll take questions from the audience in just a minute, so please come up and let me just ask this as a lead-in. What do you think will be truly disruptive? What is something you know will be true a year or two from now that you think will be truly disruptive? Maybe a data source, maybe a new way of managing, maybe new kinds of content coming out, or new forms of identification. What do you see in companies do?
I think increasingly we're going to see companies either gain or lose market share based on their ability to do this, to use big data effectively. And we're going to see companies that start on this learning curve sooner accelerate their gains. So I think it's going to be, as I said before, a basis of competition, and you're going to see companies, lose in the marketplace, and you'll say it's because they weren't good at this.
Mm-hmm. Tom?
Yeah, well, I think we've already seen that in certain industries. Certainly a lot of banks lost market share to Capital One because of analytics and so on. To me, the big development is going to be when industrial firms start doing this. I think it's, I attended the MIT Future Manufacturing conference a couple of weeks ago here, and several people said, big data is our big chance to restore manufacturing to competitiveness in the US. All these devices throw off data. You can use lots of analysis about when things have to be fixed and under what conditions, do products get created, in an optimum way. So that, I think, could be a real game changer for manufacturing.
Jim?
I think in healthcare, just the dramatic drop in cost of whole genome sequencing, that within several years, everybody in this room will affordably be able to have whole genome sequencing, and that's going to result in big data, and that, I think, we don't know what we don't know, but there's a lot of smart people waiting for that big data to crunch it.
Mm-hmm. Good time?
I think today, if you pulled aside an average business unit GM and you said, what are the three pillars? What are the pillars of your strategy? They'd say talent, capital, and brand. And I think what's going to change in the next couple of years very quickly is information is going to be added to that. That's a four-legged stool or four-legged seat. I think that's going to be different.
Okay. There is a second mic, but I'll call on you just a second. I'll give one, and I think it's economic information. I was with a logistics company that works in the cloud. I wrote about these guys recently. And their clients collectively are 3 to 5% of the world economy. And we, on a laptop, looked at a pair of sneakers being manufactured in China and headed for Portland, and we looked at all the container cargoes that were lined up in Hong Kong compared to 3 months ago and a year ago. We looked at 450,000 units of antidepressant that were heading to anti-anxiety, excuse me, that were heading to Tokyo in time for the 1-year anniversary of the tsunami. There were stories around each one of these things that were really quite deep. But the point was, if you stripped the companies and pooled the data, you started to get pretty real-time economic information about how they were feeling about the Christmas retailing season, how shipments were going to be coming out of Hong Kong compared to a year ago, how well Jordan had fared after the Arab Spring when people pulled out contracts from it. There is going to be just this wealth of abstracted data that I said to these guys, you're a content company. This is an index you could trade on Wall Street.
There's a pallet company in Australia that's doing just that. They're putting RFID devices on pallets, which has got to be the least sexy item in the world's economy, and they're tracking economic movements through the movement of pallets.
Yeah, they're everywhere and you don't see them. It's ingenious. Yes, sir.
Hi, my name is Aki. I'm with InfiniDB. We're a database company for analytics. My question is, a lot of the things that you had spoken to are analytics related, and some of them are in the big data world and some of them are not. When you think about what big data adds to the world of analytics, what does big data uniquely add, or what does it enable that wasn't possible before, or wasn't feasible, or so?
I would say not much. I mean, it's great that we can analyze this unstructured data. I mean, that's the big change, but the analytics themselves are remarkably similar. No real new algorithms, no real new tools. The big change, frankly, is people using open source tools to do analytics, R and instead of SAS and SPSS. But the tools that they're using are, for the analytics, not the data management, are virtually exactly the same.
Well, yes and no, though. But relationships and different types of data sets do change things. If you have a geographic area with 100 attributes, you can start asking all kinds of questions. And yeah, you're using the same math, but you're creating a situation in which you can talk about sentiment toward a restaurant, but you can also talk about how much meat that neighborhood is consuming. You can, the number of attributes and the relationship of one data set to another data set in some ways is the forcing issue more than the mathematics itself.
If I could just add a little bit, I mean, I think at some level of granularity, things are the same. I think at a deeper level of granularity, it is different to analyze, certain types of unstructured data, to look at images, to look at sensor data, and combine that with structured data that has traditionally sit in rows and columns. So that's real work. That being said, at a conceptual level, do correlations matter? All those sorts of things.
And speed of compute affects things too. 10 years ago, a big tough question took hours to crunch. Now you can respond to it. If you're on a web, you can change things around in real time in terms of what's laid out on the page.
I think that's right. But the other point I'd make is one that just builds on the point you just made, which is this concept of exhaust data, this data that's thrown off by pallets or thrown off by logistics companies or payments companies. Companies that have started to innovate because of the more real-time, diverse data that they have access to create new business models and capture that value in different ways. And we think that's going to change the game in a lot of industries.
Mm-hmm. And I think, Quentin, to your point, big data is going to require big judgment. You're just going to have to be much savvier about what you do with that volume of information and the speed at which you're going to have to make calls on it. And this is not just the desk trader, on Wall Street. It's folks across the business trying to make those decisions.
And paradoxically, Joey talked about just seeing patterns everywhere and just reacting all the time and A/B testing. But you have to remember, at a Facebook or a Google, that happens, yes, but in the context of extremely clear definitions about what they do. Facebook won in many ways because it had a clean interface and they didn't get very sidetracked. Yeah. They just kept doing what they did better and better. And so, on a management level, a definition around who you are and what you do becomes very, very important.
I also think specific to big data, I'll put on my IT hat. When I think about cybersecurity, I can do as much analysis as I want on the data sets within Partners Healthcare. But in fact, in the Commonwealth, there's now a group, and we're sharing our threat data in that. You get a bigger data set, and you're able to identify things that on a singular basis I would never be able to identify because I just don't have the critical mass. So we haven't talked about it, but I think that's one area you're going to really see big data put to use is in the whole cybersecurity.
Mm-hmm. Yes, sir.
Hi there. I'm Tim Doria, the founder of Boston Decision. We're a startup data mining consultancy, actually right across the street in the Cambridge Innovation Center. My question is, about 10 years ago, when I personally first started out in data mining, you used to go into Barnes & Nobles, you'd go to the business section, and you're lucky if you could find even a single book on analytics. Now you go into the same section of Barnes & Nobles, and wall to wall, the best sellers are analytics, probably in no small part because one of the panelists, Tom Davenport here.
Yeah, I've way outsold John Grisham.
Just can't stop cranking them out.
You've created competitors.
So, I mean, it's such a major change, and I'm curious where the panelists think this is going to be going in terms of businesses and startups. And let me kind of take a step back and put in perspective based on an example. So I also lead the data mining for marketer meetup over across the street as well. We just did a presentation on data mining presidential speeches to try and predict what responses candidates could say in order to best mitigate or best position themselves going forward to win elections. Mm-hmm. This led to sales folks saying, hey, can we use this to better speak to our customers and engage? And so this got me thinking, well, really you could create entire companies around analysis of publicly available information. I haven't really seen this happening all too much just yet, but I'm curious where you think this is going to go. Do you think there's a huge market for businesses that are founded in their core mission and value is to analyze data and do data mining, perhaps from publicly available sources of information? It could also be private.
So you're asking if your company has a future?
I'm curious
I'll put it up to the audience. Does my company have a future? Say, there you go.
Certainly hope so, but I'm just curious, are we just at the beginning of this, or do you see this really expanding? Do you see the analytics being a piece of what companies do, almost like an ornament on a tree, or do you see it becoming the core role of organizations, or a good deal of organizations going forward in terms of the value add they bring to their customers?
I would say both. I think there's going to be some core analytics that you're going to want as part of your company on a day-to-day basis. Then there may be some unique circumstances where I need to do an analysis of, all right, with healthcare reform, sort of where are the politicians at? What's the probability that a bill is going to pass the House or the Senate? And for that, I can see outsourcing to a niche player that's their expertise in terms of that type of analytics rather than retaining in-house, as long as you've demonstrated value and can prove that value.
There are, a lot of big consulting firms now, IBM, Accenture, Deloitte, et cetera, with big practices in analytics. But interestingly, in the big data space, it seems like most of the companies thus far want to build their own capabilities. Number of the data scientists said, we're not sure why. We know we're a pain in the ass. We're really expensive to hire and retain. But I guess people think it's so critical to their success that they have to own it.
Mm-hmm. I
think
think
go ahead.
No, please go ahead.
We are seeing companies founded with that as its basis, and we do think, some analytics is going to be core to competing, and companies that don't have it are going to fail.
Yeah.
I think we'll see the ecosystem just as we have in about any other business endeavor. That'll include some of it being done in-house. And then you'll have experts coming in, one-man shops to the Accentures and the McKinseys of the world doing that kind of stuff.
As a follow-up, I'm actually curious, and one thought I had in mind is, do you, just as an example, see, for example, like an insurance company that starts using analytics and they decide, we're actually generating so much more value on the analytics side, we're going to shut down our insurance business and be more information providers. And I'm starting to see signs that things like this could happen, and I'm just wondering if you see major shifts in terms of what current organizations might be doing going forward using analytics.
We see spin-offs, not necessarily shutting down the core, but we do see spin-offs.
Yeah.
Or, I've worked with a couple of banks that said, we have so much good economic information from credit card spending that we can start to base a lot of our decisions on our bets on equities and currencies and so on the basis of our credit card data rather than government data. I think the first time Bank of America did that, they made $300 million, at one go. So maybe they should have gotten out of their normal business. All
right. We are all content companies now.
Thank you very much.
Sure. I think we can take one more question if.
By the way, on the politics issue,
Yeah.
it's too bad in some ways that Rick Perry didn't get the nomination, because he was really into testing, and not he personally, but some Yale guys that helped him figure out, for example, that yard signs don't work and that robocalls don't work, so we could have had a whole new approach to politics.
But Tom, his candidacy didn't work.
Oh,
so-
details.
Right. Something fell down with that model.
The number one rule in political consulting is get a good candidate.
Well, let's close with. Still the corporate. Oh, is there a final? Oh, yes, ma'am.
Hi, Camila Chavez, the artist. So if you want to see my art, it's across the street at the Roach Library. And one of the things that I listen here is that we have all this data and everybody wants to do something with the data. But the reality is that we need somebody very, very intelligent and very smart to take care of this data. And we need curators. So can you define the characteristics of curators?
Well, you're drifting. I mean, in the words of that great CIO Mahatma Gandhi, people want the future so perfect they won't have to be good. And this does not liberate you from ethics, or this does not liberate you from understanding your business or understanding your customer. Like, various core human things don't really change. And anybody want to push back on that?
Not fighting with Gandhi.
On Gandhi? No, I don't think so.
Okay.
Rick Perry, yes.
There's
Gandhi,
that.
no.
Yeah. Okay. Glad we got our priorities right.
Everybody, leaving with the Mahatma. Everybody, please join me in thanking Quentin and our panelists. A few more words.